Hi 8th grade, this is Miss B here with lesson 4.01. Let's begin by going over our do now. So our do now is from our last unit on transformations, and we are told that triangle ABC was rotated 90 degrees clockwise. So remember, we are rotating to the right when we are rotating clockwise. Then it underwent a dilation at the origin with the scale factor of 4. Triangle A prime, B prime, C prime is the resulting image. So after it was dilated, this changed in size somehow. So remember, when your scale factor is greater than 1, your image is getting larger. When your scale factor is less than 1, that image will be getting smaller in size. So part A asks us, what parts of triangle A prime, B prime, C prime are congruent to the corresponding parts of the original triangle? Explain your reasoning. So the word congruent tells us that everything about the two shapes is exactly the same. Its angles and its corresponding side measures. So that word corresponding, it just means matching. So we're thinking or imagining in our head that vertex A from the triangle would match with vertex A prime, B with B prime, and C with C prime. So if it's undergone a dilation, we know that the side measures have also changed because it's changed in size. So that leaves us with only one part of these two triangles being the same, and that is the corresponding angles of triangle ABC and triangle A prime, B prime, C prime. Part B in our do now is asking us to compare the perimeters of the two triangles, ABC and A prime, B prime, C prime. Again, you are asked to explain your reasoning. So if you're not backing up your claim, you're going to lose some points here. So if we know that the side measures have changed since it's undergone a dilation, we know that the perimeters of these two shapes are going to be different. So what we need to do is explain that because they're not congruent, we know that the triangles are similar, so that their side lengths are now in proportion. Each side has changed by the same amount. In this case, it's changed by a scale factor of 4. So each side of this triangle has been multiplied by 4. And a good response for a question like this is to say how many times greater or smaller the perimeter of the triangle has gotten. So the perimeter of triangle A prime, B prime, C prime is 4 times the perimeter of triangle ABC because, again, explaining why this is true, the triangles are similar and their side lengths are proportional. So the next unit that we'll be studying is systems of linear equations. So we're going to go back to what we learned at the beginning of the year, but we won't actually start that until after the break. So what we're going to be doing over the next few lessons is strictly algebra. We're going to focus on simplifying expressions, combining like terms, and solving equations. So today, our goal is to simplify expressions by combining like terms and using the distributive property. So please take a moment and write down your I can in the notes section of your class handout. When we are combining like terms, we are adding together items that are the same to make a simplified, shorter list of items. For example, let's say you pull up to the drive-thru at McDonald's and you're placing an order. You're not going to place each individual order as 2 hamburgers, an order of French fries, a soda, 3 hamburgers, 2 French fries, and 2 sodas. Right? You're going to want to make the person's life a lot easier by saying that you want 5 cheeseburgers, 3 French fries, and 3 sodas. Right? So it's the same idea with algebraic expressions. We're going to be combining things to make a simplified, shorter list. So instead of having 3 separate like items, we're going to group them with like terms. Let's take a look at example 1 in the notes section of your handout together. So what we have here is a monstrosity of an algebraic expression, and our job is to condense it, simplify it, and make it as small as possible so we don't have this really long algebraic expression on our handout. So you might see a new symbol on this page, and that is a bracket. A bracket is just another grouping symbol. So when we've learned order of operations in the past, we've used PEMDAS, right? Parentheses, exponents, multiplication, division, addition, and subtraction. So remember, multiplication, division, addition, and subtraction, you always work from left to right when you're just left with these two operations. So because we don't only have parentheses, and we won't only be working with parentheses, we're going to turn this P into a G. So GEMDAS, that looks sloppy. So GEMDAS stands for grouping symbols, exponents, multiplication, division, addition, subtraction. So we're looking at parentheses and brackets today. So what grouping symbols tell us to do is work from the inside out. So I'm going to walk you step by step through this example. So in this case, we only have one variable, and that's x. And we also have constants, which are the numbers that are by themselves that aren't multiplied by any variables. So our first step in this example is to focus on simplifying what we have inside of the grouping symbol, inside the brackets. So anything that we have on the outside is going to stay exactly where it is. We can't do anything with negative 19x or the negative 5 that's on the outside of our grouping symbol. So the first thing we're going to do is try to get rid of these parentheses. And the way that we're going to do that is by applying the distributive property. So with distributive property, you're multiplying the term on the outside of your parentheses by each term on the inside. So since we don't have 2x with a set of parentheses to multiply, 2x is another term that we can't do anything with just yet. So we have 4 times x, which is a positive 4x, and we have 4 times 2, which is 8. So now that we've gotten rid of that first set of parentheses, we're going to move on to the negative 3. So now notice I said negative 3 and not just 3. In algebra, whatever sign is in front of that number stays with that number. So we are distributing a negative 3. So negative 3 times positive 9x is negative 27x. And negative 3 times negative 2 gives us a positive 6. Don't mind my work. It's a little difficult to write on this iPad. So that's a plus 6. And we are ending it with a bracket. So we've gotten rid of our parentheses. Our next job now is to get rid of the brackets since we're still following the order of operations. So I'm going to move a little to the left so I have more space. So negative 19x minus 5. We still can't combine just yet. So what we're going to do next is simplify everything that we have inside of these brackets once we get rid of those parentheses. So what I recommend doing is circling and boxing or putting the same shape around your terms that are the same. So we have all our terms with an x. We have 2x, positive 4x. Notice I circled the sign that's in front of that term as well. And a negative 27x. So 2x and 4x gives us 6x, and 6x minus 27x is negative 21x. So now that we've combined the coefficients on the terms with the variables, we're going to go on ahead and add our constants. So we have a positive 8 and a positive 6. So 8 plus 6 gives us a positive 14. So we have plus 14. So notice we haven't yet gotten rid of these brackets. But what we're going to do is treat these brackets just like we would parentheses. And notice we have a term on the outside of our brackets. We have a -5 there. So the way that we're going to eliminate these brackets is by distributing the -5. So we have -19x on the outside. We have -5 times -20, which is a positive 105x. And lastly, we have -5 times positive 14, which is a -70. So when you're simplifying expressions, you need to be extra careful with your integer operation. So you need to be careful with whether the result is going to be positive or negative. So now that we've eliminated our grouping symbols, we can go on to the following letter in our order of operations. So we don't have any exponents. We don't have any multiplication or division left, but we do have addition and subtraction. So remember, we work from left to right. So we're going to combine our last two terms that are the same, or last two like terms, -19x and positive 105. And the result is -86x plus 70. And this is our final answer. So we've gone from this really long expression to this simplified version of it, -80x plus 70, by following the order of operations. Please take a moment to do example 2 on your own and unpause this video for a step-by-step solution. Be sure to show all your work horizontally. So every little thing that you're changing, you are rewriting your expression on the next row. So our first step in the order of operations, again, is to work from the inside out. Since we have two grouping symbols, we have to work within the brackets to eliminate the parentheses. And the way that we're going to do that is by using the distributive property. So everything else that comes before it stays exactly the same. Our next step is to simplify what we have within those brackets, which is a 3x and a 5x, to positive 8x minus 30. And the way that we're going to eliminate these brackets now is by distributing the term that we have on the outside, which is a -8. So -8 times positive 8x is -64x, and -8 times -30 is positive 240. And finally, we're going to combine whatever like terms we have remaining, which is our two constants, 28 and 240, which results in 248. And the -4x we would write as our first term, because normally when you're writing something in standard form, the term that has your variable comes first. So your final answer would be -64x plus 248.